This is the homework video for lesson 4.2 in the textbook. We're looking at equations for horizontal and vertical lines. Number 1, list 3 ordered pairs whose y-coordinate is 4. So first of all, the coordinate is your x and your y. So we're looking specifically here at the y's. They all have to be 4. So you can make up anything you want. But a 4 needs to be in this position on all your coordinates. So whatever number you put in the first spot doesn't matter. I'm going to put -1, 0, and 1, but you can put anything you want. We just need a 4 as the y coordinate. Okay, part B, we're going to quickly graph that and see what that looks like. The key is the y is 4, so 1, 2, 3, 4. So 0, 4 is going to be right here. 1, 2, 3, 4, 1, 2, 3, 4. -1, 4 is back 1, up 4. 1, 4 is over 1, up 4. And regardless of what you chose as your x values, the y's are all going to be up here. And so we're going to go ahead and draw a line through this. Write the equation of the line, because on part B we're also supposed to draw the line through them, which we did. And the equation is, well, think about what changes here, the x values. What does not change? The y values. They're always 4. This is the line y equals 4. So whatever value is not changing, that's the variable that you're going to use in these equations to say y equals or x equals. Okay, that was part C. Number 2. So we're just going to write an equation for each graph, nice and easy. So if you take a look at this graph right here, the x values are changing. We're going left to right. 1, 2, 3. The farther to the right you go, the x value gets bigger. The farther to the left you go, the x value gets smaller. What's not changing? No matter where I go on this, the y value is -2. It's down 2, -2. So whatever's not changing, that's the letter you're using, y equals, and it's -2. Number 3. This is the opposite now. Okay, this is vertical, up and down. So the y value is changing. Up here I'm in the positives, down here I'm in the negatives. Right here I'm 0, but the x isn't changing. I'm always at -4. Any point that I look at on this line has an x value of -4. So this is x equals -4. Okay, moving on, number 4. So fill in the blank, all points on a horizontal line. So when I see the word horizontal, I remember that looks like the word horizon. When you look to the horizon, it goes left to right. So a horizontal line is going left to right, and they all have the same what coordinate. So the x value changes on these as you go from left to right, but the y value doesn't change. And number 5, all points on a vertical line, straight up and down. The y's get bigger, the y's get smaller, but the x value does not change. So all points on a vertical line have the same x coordinate. Okay, number 6. 6 and 7, we're going to graph the points on a number line that satisfy this equation, and then we're going to graph the points on a coordinate plane. So what's the difference between a number line and a coordinate plane? So we've been using number lines with our inequalities. They just look like this. And so there's 0, 1, 2. X equals 2. We're going to put the circle on it. We're going to fill it in because it is included. It is the only value here. And we're not going to shade anything because this is not greater than -2 or less than -2. It's just equals. The only point on this graph that equals 2 is right here. Okay, next they want you to put this on the coordinate plane. So this looks a little different now. So I'm going to go to x equals 2, and I'm going to put a point. Now, where else on this graph does x equal 2? Well, up here. X is still 2. The y value has changed, but x is still 2. And down here, the y value has gone negative. The x value is still 2. So anywhere we go on this line, on a coordinate plane, x equals 2. So number 7, same thing for a y value. So a number line is a number line. We're still not changing it for an x or a y. So here's 1, here's 2. 1.5 is going to be right in between them, with a filled in circle because it includes it, and that's it. That's the only point on this number line where y equals 1.5. Now on a coordinate plane, there's an infinite number of points that have 1.5. So here's 1, here's 2, here's 1, here's 2. Gotta be careful now. This one says y equals, so we're going to where y equals 1.5, not x. So y equals 1.5 right here. Where else does it equal 1.5? Anywhere up here. The x value is 2, but the y value is still 1.5. The x value goes negative, but the y value is still 1.5. And so this line, no matter where you go on it, y equals 1.5. That was number 7. And we don't have to do number 8. Sorry about that. Number 9. All right, we're looking at this graph. You can see we've got this line. They've labeled it the mean. So the graph shows the annual snowfall on this mountain in Oregon, and the mean snowfall, the average snowfall, is 98.5 inches per year. So on average, they get 98.5. And that's what this line represents, the average snowfall. So this information is important to the water supply in the region and also for the people who ski. Okay, so they're just putting some value on those numbers. So number 9. Letter A. Let S be the snowfall in year Y. What is an equation of the line that is graphed? So the reason they said let S is they don't want you to use a Y or an X. If you notice their graph here, this is labeled S and this is labeled Y. Now I don't like that they use Y because we're used to the Y axis and the X axis. So to me, if you're going to change up the variables, don't use a Y. Use something else. So this is S, that's fine. This to me should be something else. I get that it's years, but if you're going to put them down here to label it Y is a little confusing. But regardless, the value on this line never changes for S. It's always 98.5. The years change, but S doesn't. So this is S equals, and then what's the value that it always is? 98.5. So that is the equation of this line. And then letter B, which year has the greatest absolute deviation from the mean? So deviation means going away from. When you deviate from a plan, you change the plan, you go away from it. The absolute deviation, absolute meaning it doesn't matter if it went up or down, absolute value, positive or negative, doesn't matter. What's the greatest distance away from the mean? So as I look at all these dots, which one is the farthest from the mean? This one right here, and the year there is 1997. That one deviated the farthest from the mean. Okay, number 10, which year snowfall was closest to the mean? So which dot is closest? So right here, 1998. What does that tell you about its absolute deviation from the mean? So we talked about early on in this year, we actually found the absolute deviation. So remember, we found the mean, and then we found out how far each piece of data was from the mean, and we averaged it out. Okay, so comparing this to these, is this going to have a bigger or a smaller absolute deviation? So the closer it is, the deviation will be smaller. Whereas in 1997, that deviation is going to be bigger. And that's just the measurement of how far it is from the mean. So we don't have an exact value here, but it's pretty close to 98.5. That deviation was maybe 1 or 2. And then 97 up here, we can see it's over 150. So we're 50 something away from the mean. The deviation is 50 something, and this deviation is like 1 or 2. So this deviation is smaller, this deviation is bigger. Number 11, in which 2 consecutive, that's in a row, years was the deviation negative? So negative meaning it was underneath. Okay, so notice they didn't use the word absolute. So absolute is just measuring how far it is. But it can have a negative deviation, meaning that it's under. So all of these dots have a negative deviation. These all have a positive deviation because it was over. So this year it was a negative, but then the next year it went positive. But right here, a negative and a negative in a row. So it's from 2000 to 2001. Pardon the heater. Sounds sort of like a Halloween haunted house or something. Letter B, was this good or bad news? So now they want you to come up with the fact, was this good or bad for people in Portland? And I would say bad. Not good skiing. And you could say something about the water supply. They referred to that as well. Okay, that was 11. 12 and 13, we're going to look at these points and we're going to write the line that goes through them. So basically all you have to do is figure out, is the x value staying the same, is the y value staying the same? Because all of these lines we're writing are horizontal and vertical. So on number 12, the y value is consistently 12. The x changes, the y is always 12. Nice and easy, that's y equals 12. That's it. So 13, what's not changing? The x value is not changing. The y value changes, the x does not. So this is x equals negative 6. 14, horizontal line. So horizontal line goes left to right. The y value doesn't change. The x goes negative to positive. The y value doesn't change. So this is y equals, and then what's the y value that it always hits? Negative 13. So what about the same point with the vertical line that goes through it? So the y value gets bigger and smaller, but the x value stays the same. That's x equals 7. 15. Horizontal lines are parallel to, so horizontal lines go like this. They run parallel to the x-axis and perpendicular to, meaning it hits at 90 degrees. So this is right here, this is a horizontal line, runs parallel to the x-axis, and there's a 90-degree angle right here. That's what perpendicular means. Hits the y-axis at 90 degrees, so it is perpendicular to the y-axis. Okay, 16, we're going to match A, B, and C. So A, B, and C. We're going to match them to the correct graph. So I'm going to start with these two graphs right here. In this one, I see my x value get negative or positive. What doesn't change? The y value doesn't change, and it should be negative. So I'm going to look for a table where the y value is negative and it doesn't change. That's right here. So C goes with I. I'm going to go over to this one. Y values are changing, but the x value doesn't change. X value is the same anywhere on this line and is again negative. So I'm looking for the table where the x value stays the same and it's negative. That's letter B. So that matches the triple I. And then clearly this one, my x changes, my y changes. Anywhere on this line, any diagonal line, the x values change, the y values change. Okay, so letter A is this one. 17. Predict where the lines y equals 5 and x equals 7 will intersect without graphing. So just visualizing this. Y equals 5 is up here. X values change, but the y is always 5. And x equals 7 is like this. The y values change, but the x is always 7. So where do they hit? They're going to hit over here somewhere. And I know no matter where I go on this one line, the x line, it's going to be 7 for the x value. And I know no matter where I go on this line, the y value is going to be 5. So at that point, the x value has to be 7 if it's on this line, and the y value has to be 5. So you're literally just going to combine those numbers, and that's the spot that they're going to cross. And last one, number 20. Write an equation for a line that goes through these points. And you look at it and you're like, well, how do I do that? There's variables, there's no numbers there, but which value is not changing, the x or the y? That would be the y. And so this is a line. So even if you plugged in for m, it's going to be the same number anywhere you go. So the y value is not changing. Okay, this is a horizontal line. And the value, we don't have it, it's a variable, is m. So it's y equals, if I plugged a number in here, you would say y equals that number. So it's just y equals